students, welcome to my class. In this video we are going to be discussing about work energy theorem related questions. The first question says the displacement of the body of mass is given as 2 kg and which is varying with the time is given as s equal to t square plus 2t, where s is in meters and t is in seconds is given. The work done by all the forces acting on the body during the time interval t equal to 2 seconds to t equal to 4 seconds they are asking. So displacement of the particle which is varying with the time is given, s equal to, here you can write as t square plus 2t. Now when you are doing differentiation, this displacement v equal to, here rate of change of displacement, here we will be getting this is nothing but 2t plus 2 we will be getting. Now first let us calculate at t equal to 2 seconds. At t equal to 2 seconds, first we need to calculate its velocity. Then velocity v1 which will be equal to, here we will be getting as 2 into 2 plus 2 will be rating. We just substitute here, which is nothing but we will be getting as 6 meter per second we will be getting. Then at the time t equal to 4 seconds, here again you have to calculate its velocity. v2 equals will be getting as 2 into 4 plus 2 will be getting. So here 8 plus 2 will be getting as 10 meter per second will be getting. The work done by all the forces they are asking. According to the work energy theorem, work done by here right, all the forces which will be equal to change in kinetic energy. Change in kinetic energy you can write as half m into, here you can write it as v2 square minus v1 square you can write. We need to calculate here velocity at a particular time intervals we need to calculate. So here you just substitute these values. Here mass is given as 2 kg is given. This is 2 kg into, here you will be getting as v2 square, in the sense here it is 10. It's a 100 minus, here 6 are 36 will be getting, this 2 gets cancelled, 100 minus 36 will be getting as 64 joules you are getting. So 64 joules is the correct answer. Let us see the next question. A particle of mass 0.01 kg, it's given as travels along the curve with a velocity of, here it's given as 4i plus 16k it's given. So here velocity, here it's given as, it's 4i plus 16k it is given, it's meter per second it's given. Now after some time its velocity becomes, here it's given as 8i plus 20j meter per second. Means the particle is moving in a 3-dimensional plane, students. Here this is the initial velocity is given, and let us calculate first this magnitude. This magnitude of this velocity v1 which will be equal to, so for the 16 you will be getting, and here and 16s are here will be getting as 256 will be getting. This is the magnitude of velocity, together we will be getting as 272 under root will be getting. Now here later it is going to be changing it to the another plane. So here it is given as 8i cap plus 20j cap it's given. Now again you just calculate its magnitude, so 64 plus it's 400 will be getting. So here together we will be getting as 464 will be getting under root. Now here we need to calculate the work done on the particle during this interval of time they are asking. Now here work done is nothing but, here you can write as, this is a change in kinetic energy, half m into, here you can write as v2 square minus v1 square, which is nothing but, here you can write as half into, mass is given as 0.01 kg, here you just take it as 1 by 100, v2 square you can take square, you have to cancel, this is v2 square is nothing but 464 minus, here you can write it as 272 you can take, which is nothing but, here we will be getting as 200, and here you can take this is 192 by, here we will be getting as 200 will be getting, it's here nearly will be getting as 296 times it is going, and here we will be getting as 0.96 joules you are getting. 96 by 100 you can take 0.96 joules is the correct answer. Let us see the next question. The velocity of the particle moving along a line varies according to the distance is given. V is a function of distance is given. V equal to a into square root of x is given. Now the work done by all the forces when the particle moves from x equal to 0 to x equal to L they are asking. First let us calculate here at x equal to 0. at x equal to 0, first you need to calculate its velocity. At x equal to 0, when you are substituting here, its velocity becomes 0. Now here you can take at x equal to L distance, in the sense here v equal to will be getting as a into root L will be getting. Work done by all the forces is nothing but here work energy theorem we can take. Here it's nothing but work done equal to, you can take as change in kinetic energy. It's nothing but here you can take as half into m into, here you can take as this is v2 square minus v1 square you can take. Let us consider this is v1 and as well as v2, and here you can take half into m into v2 square, in the sense here a square into L will be getting. This is a square into L you are getting, which is nothing but here will be getting as m into a square into L by 2 will be getting. This is a work done value. Half ma square L is the correct answer. Let us see the next question. A block of mass 2 kg initially at rest on a horizontal frictionless surface. A horizontal force which is going to be acting, and here it acts on it. The block is at x equal to 0. The maximum kinetic energy of the block between x equal to 0 to x equal to 3 meter joules they are asking. So here it's given as, here since this is a 2 kg block will be initial at rest is given. Initial it's going to be at rest on a horizontal frictionless surface. This is a smooth surface is given. A horizontal force which is going to be acting, and this is a variable force is given. F equal to, here it's given as, here it is given as 9 minus x square is going to be acting along the x-axis. Now here when the block is at 0, the maximum kinetic energy of the block between x equal to 3 to x equal to 0 to x equal to 3 meters. Now here you will be getting as this block has been displaced like this, here up to 3 meters distance. Now just calculate the work done. So work done here, a force is given as, it's a variable force. Now work done is nothing but here for a variable force you can take integral, here we will be getting as f into dx. Within the limits you can take initial distance to the final distance you can take. Work done is nothing but here it's nothing but change in kinetic energy according to the work energy theorem, which will be equal to, here initial distance will be 0 and final distance will be 3, and here for the variable force here it's given as 9 minus x square into, here you can take as dx. Now here when you are doing integration, here 9 into dx integral, 9 into here will be taken as integral dx. Within the limits 0 to 3 you can take minus integral x square into here dx you can take, within the limit 0 to 3 you can take. Now when you are substituting here 9 into integral dx is x you are taking, you just put the value here, will be getting as 0 to 3. Integral x square, in the sense x cube by 3 you will be getting, within the limit 0 to 3 you can take. So here we will be getting as 9 into upper limit minus lower limit minus, here this is upper limit, in the sense 3 you have to substitute, 3 cube in the sense 27 by 3, it's 9 will be getting minus 0 will be getting. So here we will be getting a 9 3s are 27, 27 minus 9 will be, here nearly will be getting as 18 joules will be getting. So therefore change in kinetic energy is nothing but here will be getting as 18 joules is the correct answer. Let us see the next question. The energy required to accelerate the body from 30 meter per second to 60 meter per second is 3 times the energy required to accelerate it from 10 meter per second to v they have given. The value of v they are asking. The energy required to accelerate, in the sense here according to work energy theorem you can take, here work done is nothing but change in kinetic energy I am just taking. Now here you can take the ratios of the change in kinetic energy is, this is delta E1 by, here you can take as delta E2, which will be equal to half into, here same as, this is here initial velocity will be getting as the 60 meter per second it's given, 30 meter per second, final velocity will be 60. So final velocity is 60 whole square minus 30 whole square you can substitute by, here it is getting as half into m into, here final velocity is v, initial velocity will be 10 it is given, Then here V square minus here you can take as 10 square you can take. But this kinetic energy is given as here, first kinetic energy is given as 3 times the energy required to accelerate the second body. So here you can take as 3 times of delta E by here you can take as E you can take half m you just remove. Here you can get it as 60 or 3600 minus 900 by here will be getting as V square minus 100 will be getting. So here this is delta E, you just cancel. Then here you just cross multiply this one, 3V square minus 300 which will be equal to 3600 minus 900 will be getting as 2700 will be getting, and this is 3V square which will be equal to here 3000 will be getting, and here velocity here will be getting as 1000 will be getting, and here velocity here when you are taking this is V square equal to 1000 meter per second. Even we can write this one as 10 root 10 we can take. This is 10 root 10 meter per second is the correct answer. Let us see the next question. A body of mass m accelerates uniformly from rest to a speed of v0 in a time. So here it's given as a body is going to be accelerating. Acceleration, the formula will be getting as here will be getting as change in velocity by time it's given. The work done on the body till any time t is they're asking. So work done we need to calculate here. Work done it's nothing but force into displacement of the body. So here force causes some acceleration you can take according to second law of motion into s you can take. Here they are not given any direction, so that you can take here both are moving along the same direction. Fs cos 0 you can take, mass into acceleration you can get into displacement. Now here you can take here this is m into here with what acceleration the body is moving. Here initially starts on the rest is given, so here you can write it as displacement covered by the body in the sense here s equal to ut plus half at square you are getting, and initially starts from the rest. Here you can write as half at square you can write. Hence here we will be getting as m into here you can get it as this is instead of here a here this is a you can take, displacement is nothing but half at square you can take. Then here we will be getting as half into m into a will be getting as a square into t square will be writing. Therefore work done which will be equal to here half into m into acceleration we know this is v0 square by t0 square will be getting. So it is going to be accelerating in this time interval t0 seconds into you can write as t square. This is the work done during this time interval t we need to calculate, but acceleration time is given as t0 is given. So this is the correct answer. Half into m into v0 square by t0 square into here we will be getting as t square you are getting. Let us see the next question. A body of mass 2 kg is projected vertically up with a velocity 100 meter per second. So here you are taking a body you are going to be taking, you are projecting vertically up like this. This is the body, this is the mass it's given as 2 kg mass it is given. With the velocity here it is given as 100 meter per second velocity you are projecting. It rises to a height is given. So here it's nothing but you can take as maximum height you can take. 400 meters is going to be rising. The energy utilized to overcome the friction. Means when the body is going to be moving here, some air resistance is going to be opposing along this direction. Now here we need to calculate here the energy utilized to overcome the friction. That doesn't mean here work done against the frictional force you need to calculate. When the body you are projecting two forces it's going to be acting. According to the work energy theorem, work done by all the forces which will be equal to change in kinetic energy. First you have to identify what force is acting on the body. One force will be the gravitational force, second force is the air resistance or air friction is going to be acting opposite to this one. So work done by here we just calculate for all the forces. One is gravitational force and second one is the frictional force, which is nothing but change in kinetic energy half m v2 square minus half m v1 square you can take. Work done by the gravitational force. Work done against the gravitational force you are moving the body. So it's nothing but work done against the gravitational force is minus mgh, plus here we need to calculate this work done against the frictional force. So after reaching the highest position here, the final velocity you can take as 0 you can take. So here final kinetic energy will be 0 minus half into m into v1 square you can take. Now I just substitute these values here, will be getting as minus 2 into mass is given as 2 into g is given as 10 into h value it's going to be rising as 400 meters plus work done by the frictional force minus half into mass is given as 2 into velocity, here you can take as 100 into 100 you can take. So 2 gets cancelled. Now here when you are simplifying this one, here you will be getting as this is work done by the frictional force, this is it's nothing but this is 10,000 you will be getting minus here you will be getting this is 2 10 20, it's 8,000 you will be getting. So minus it becomes plus, here of course this minus value, here plus, here you will be getting as 8,000 joules you are getting. So work done by the frictional force is nothing but minus 2,000 joules you are getting, it is nothing but minus 2 kilojoules we can take. So frictional force is an opposing force, so here in options here they are not mentioned any minus value, we need to take as minus represents an opposing force. So here the answer will be 2 kilojoules. Let us see the next question. The next question says a body of mass 0.1 kg released from a height of 50 meters. This body is given and here its mass will be 0.1 kg it's given, and you are releasing from a height of, here it's given as 50 meters height you are releasing, and it reaches the ground with the velocity, here it's given as v equal to 10 meter per second it's given. The work done against the air resistance they are asking. Means when the body is going to be moving down, some air resistance is going to be opposing the motion of the body, thus the air friction you can take. Now let us take here according to the work energy theorem, work done by all the forces which will be equal to change in kinetic energy. Work done by all the forces in the sense, one force is the gravitational force is going to be acting, another force is the air resistance is going to be acting in upwards. So here work done by the gravitational force plus work done by the frictional force, which will be equal to, here you can take as half into m into v2 square minus half into m into v1 square you can take. So body is moving down in the sense, here body is going to pulling the body, here gravitational force. So force and displacement both will be along the same direction, then work done by the gravitational force is positive, so mgh will be getting plus wf, which will be equal to half into m into v2 square you can take. Initial velocity releasing the body, you are releasing the body means initial velocity you can consider as 0. Now here you just substitute, here mass is given as 0.1 kg, g you can take as 10, from what height you are releasing 50, here work done by frictional force half into mass is 0.1 into v square. So finally when it is reaching the bottom, so the velocity will be 10 square, you can take as 100 you can take. Now here when you are simplifying all these values, here work done by the frictional force will be getting as, here 45 joules you are getting. Here we just cancel 250 times, and here we will be getting as this 10 and this 0.1 gets cancelled and this 10 gets cancelled, and here we will be getting as 50, 5 minus 50, it's nothing but 45 joules will be getting. So this is a work done by the frictional force value 45 joules. Let us see the next question. A block of mass 100 kg is pulled upon an inclined plane of length is given as 10 meter and 3 meter high by constant force of 400 newtons. Now here it's given as one inclined plane, it's given. This is an inclined plane, it's given, and here this height is given as 3 meters is given. Now here a block will be, you are pulling, and here it's a inclined plane length is given. Here this length of the inclined plane is given as 10 meters is given. So you are pulling the body with some force. So here work done against the frictional force is given as 200 joules. That doesn't mean here the surface is the rough surface, you just imagine. Now here we need to calculate the velocity of the block at the top of the inclined plane, you can take. So here when it is reaching the top of the inclined plane, with what velocity it is going to be reaching. So this is a question they are asking students. Here first you need to identify, so what force is acting on the body. So here what forces here acting on the body means, one is applied force. So here second one is the gravitational force. Suppose here you are taking, it's an inclined angle theta you are taking, this is here you connect as mg, and here you will be getting as, this is a normal reaction, and here it will be, this is when it's making an angle theta, this is here will be getting as mg cos theta will be getting, and here perpendicular to this one will be getting as mg sin theta will be getting. Now here second force is applied force, and third force is the frictional force is going to be acting. Now here work done by all the forces doesn't mean, here one is work done by the gravitational force plus work done by the applied force plus work done by the frictional force, which is nothing but change in kinetic energy contact. Now here you just apply the things here all. Work done by the gravitational force is nothing but here minus mg sin theta. So work done is nothing but force into displacement. Here force is nothing but gravitational force is going to be pulling the body downwards. Displacement will be opposite direction. So force and displacement both will be in opposite direction. So that I am writing as minus mg sin theta into L. So here the work done by the gravitational force will be negative plus, so work done by the applied force means here applied force and displacement both will be along the same direction. So that work done will be positive plus work done by the frictional force, which will be equal to half into m into, finally it is attaining certain velocity. Initially the body will be at rest. So these are the things you need to note down, students. Here mass is given as, here you just substitute this values 100 into g value is given as 9.8 into sin theta. Sin theta is nothing but here you can take as, this is opposite side by adjacent side. Here you can get it as sin theta into L. L is given as, here you can take as sin theta from this triangle. This is from this triangle, here will be getting as 3 by, here you will be getting as 10, you will be getting opposite side by hypotenuse is nothing but 10 is the length of the inclined plane will be getting, into length in the sense here you will be getting as 10, you will be getting this length. So sin theta will be 3 by 10 plus force, it is given as 400 newtons you are applying, into length value will be 10. So here and second thing, next thing is here work done by the frictional force. Here work done by the frictional force in the sense, here work done against the friction is given as 200 joules. So against the friction in the sense, here it's going to be acting opposite to the direction of the motion of the body. That value will be minus will be getting. So here minus 200, which will be equal to half into 100 into, you can take as v square, you can take final velocity. So here this 10 gets cancelled. Here you can substitute these values, 100 into this 9.8. So here you will be getting as 400 into this one. So here we will be getting as minus 980 into 3 plus this is 4000 and minus 200, which will be equal to, this is 50 times it is going, and here 50 into v square you are getting. So when you are calculating and simplifying these values, here nearly will be getting as velocity value, here will be getting as 4 meter per second you are getting. So 4 meter per second is the correct answer. Let us see the next question. A bullet emerges out. A bullet is going to be emerging out from the wooden plank with 75% of its initial kinetic energy, and the number of additional planks are required to stop the bullet is. So here one plank is given, a wooden plank is given, and here a bullet you are going to be firing, and the bullet when you are firing here, it's going to be losing its kinetic energy, 75% of its initial kinetic energy, it's coming outside. When it's coming outside here, 75% of the kinetic energy of its initial kinetic energy. Means here 25% of the energy it's going to be wasting. The remaining energy it's going to be 75% alone will be present. How many such additional planks are required to stop the bullet? Means here 25% it is going to be losing. How many such planks are you are going to be placing like one upon the another like this? So here so the block it will be coming to the rest position they're asking. Let us calculate here work done by the which will be equal to here work done by the forces, work done by all the forces which will be equal to change in kinetic energy, Ke final minus Ke initial you can take. So here this is here against the resistive force is going to be acting, right? Bullet when it is firing, some resistive force opposing the motion of the bullet. Let us take that is I am just taking as minus force into opposing force into displacement. It is a kind of frictional force, you can take assumption. Final kinetic energy means here 25% the energy is losing, remaining values alone we can talk. So it's a 75% means 75 by 100 K you can take minus initial kinetic energy you can consider as K. Let us take this is the first equation. Second thing here you can take as how many such planks are required to stop the bullet. So again here stopping the bullet in the sense here n such planks you are going to be keeping. They are traveling a distance here some x distance you can take for each bullet. So here n times of the right x you can take, which will be equivalent to 2. So finally it is coming to the rest you can take 0 minus initial kinetic energy you can get it as K you can take. Let us take this is equation 2 you can take. You just simplify the 1 and 2. So 1 by 2 when I am talking. So fx and here fx gets cancelled, minus you have to remove. So here we will be getting as 1 by n, which will be equal to this is 75k minus 100. Take the LCM. Here we will be getting as minus 25k by here we will be getting as 100 into here and denominator will be getting as minus k. Minus gets cancelled. This kk you have to cancel 25 4 times. So how many such planks are required in the sense here 4 planks are required to stop the bullet. Let us see the next question. The next question says a bullet of mass 10 gram hits a fixed target and penetrates through 8 centimeter. Bullet mass is given and here it's going to be penetrating through 8 centimeter. So here you are taking on target you are taking. This is a target you can take and here a 10 gram bullet it's going to be firing like this. It's penetrate into 8 centimeters given. This is here you can take that. This is 8 centimeter distance it is traveling. It before coming to the rest. If the average resistance offered by the target is 100 newtons, the velocity with which the bullet hits the target they are asking. With what velocity the bullet is going to be hitting the target they are asking. This is the initial velocity we need to calculate. Means work done by the force, bullet force we can take, which will be equal to here we can get it as change in kinetic energy. Change in kinetic energy means Ke final minus Ke initial you can take. Work done is nothing but here you can take as there is a resistive force, average resistive force offered is given as it's a minus force into displacement. So here force and displacement both will be acting in body is going to be moving along this direction. So here its opposing force is going to be acting along this direction. So that I am taking as minus F into x, which will be equal to finally when it comes to the rest, right, before coming to the rest they are given. So 0 minus here you can take as half m v square you can take. So here already here the resistive force is given as 100. It is going to be given as 8 centimeters traveling, 8 into 10 power minus 2, which will be equal to minus half into mass will be 10 grams. Here you just take as 10 power minus 3 kg into v square you can take. Here 2 zeros gets cancelled, 10 power minus 2 gets cancelled. Here minus gets cancelled. Here 1 10 and 10 power minus 2 you can take. It becomes 10 power minus 2. And here 2 8 are 16 you will be getting. and here you will be getting as 16 by this is 10 power minus 2, which will be equal to v square. It's nothing but v square equal to, will be getting as 1600. That means v equal to, will be getting as 40 meter per second. Will be getting, means the bullet initially it's going to be hitting the target with a velocity of 40 meter per second. Let us see the next question. A bullet fired into the trunk of a tree, it loses 1/4 of its kinetic energy in traveling a distance of 5 centimeter. Before it stopping, it travels a further distance of. Now your firing into the trunk is given. Here a tree it's given, and here you can write as this is a tree trunk. You just imagine. Here you are firing the bullet. It loses 1/4 of its kinetic energy in traveling a distance of 5 centimeters. So here this is traveling 5 centimeter distance into the trunk, and before stopping it, it travels further distance of how much further distance it's going to be traveling. Here to here you just calculate. Let us calculate here the work done, which will be equal to here work done by the resistive force, which will be equal to change in kinetic energy. You can take Ke final minus Ke initial. You can take, means force and displacement, opposing force and displacement will be both in opposite direction, so that you can get it as work done will be negative force into initially displacement will be 5 centimeter. Let us take the first case. 1/4 of energy it's losing, in the sense remaining energy alone we can talk. So final kinetic energy will be having 3/4 of its kinetic energy minus initial kinetic energy. You can take as K. Let us take here, this is first equation. Now finally when it comes to the rest, it is furtherly it is going to be traveling some x distance. You can take in the second scenario, and here final kinetic energy will be 0. Come to the rest. So here initial kinetic energy, here to here it is traveling. Here how much energy will be having in this sense? 3/4 of kinetic energy will be having from moving to here to here. So here you can take this, this is 3/4 of K. You can take. Let us take this is equation 2. Now you have to simplify this one. Here 1/2 when you are taking. Here this is here when you are dividing these two, minus gets cancelled, FF gets cancelled. Here 5/x, which will be equal to 3/4 minus 1. Here it's minus K/4. And this is nothing but minus 3/4, 3K/4 will be getting, and here you can take as minus 4/3K. 4 gets cancelled, KK gets cancelled, and x value will be getting as 15 centimeter will be getting. So this is 15 centimeter is the correct answer. Let us see the next question. A vehicle of mass 100 kg is moving with a velocity 15 meter per second. It is brought to rest by applying the brakes and locking the wheels. So initially a vehicle is moving with a velocity of 15 meter per second is given. It's brought to rest by applying the brakes. If the sliding friction between the tires and as well as the road is given as 6000 newtons, distance moved by the vehicle before it comes to the rest. Here also work done by the applying brakes or work done by the that braking force, which will be equal to, here you can take as Ke final minus, here you can take as Ke initial. You can talk. So resistive force and displacement, the frictional force is going to be acting. So it's nothing but here you can get it as frictional force into displacement. So car is moving this side, here opposing force or frictional force is going to be acting along this direction. So work done will be negative will be getting. So here you can get it as finally when it comes to the rest, final kinetic energy will be 0 minus initial kinetic energy. You can take as half mv square. How much frictional force is going to be given in this sense? Here 6000 newtons is given, and here it is going to be traveling. Here x is the distance covered before it stops, which will be equal to here minus half into m. Mass is given as 1000 into velocity is given as 15 whole square. You can take. So here when you are simplifying this one, here this is 1000, here you will be getting as 6 times it is going, minus minus gets cancelled, 2 6 are 12 you will be getting here, or else here you can get it as x value we need to calculate. So x is nothing but here we'll be getting as 15 15 are 225 by here 2 16 are will be getting as 12 will be getting. So when you are simplifying this one here x value will be getting as nearly 18.75 meters you are getting. So this is the further distance covered before it comes to the rest by the car. Let us see the next question. The next question says a particle in a straight line, it's moving here, it's given as with its retardation proportional to its displacement is given. So retardation is nothing but here you can get it as minus a you can take, which is directly proportional to here it's a displacement some x is given. So here we can talk about one its magnitude, students. Here instead of proportionality here I am just taking as some a equal to here I am just taking as kx. So acceleration here we need to take as v into this is here dv by dx, which will be equal to k into x you can take. It loses here kinetic energy by any displacement x is proportional to their asking. So kinetic energy they are asking here, we need to calculate the kinetic energy, then here v into dv, which will be equal to k into x into dx you can take. When you are doing integration on both sides, here you can take like this, integral v dv. V dv is nothing but here will be getting as v square by 2, which will be equal to k into here will be getting as x square by 2 will be getting, and here you can take on both sides when you are taking as m, here you just multiply with the m value. Here it's nothing but here will be getting as kinetic energy. So loss in kinetic energy, this is nothing but body is going to be stopping here you can take. Here you will be getting as this is kinetic energy loss you can take, which is directly proportional to how it is related to the x value they are asking. So it's k, m and all the values you can make it as constant. Here you can take it as directly proportional to x square you can take. So loss in kinetic energy doesn't mean here you can put the value will be minus, right? Here or else here this minus value you have to continue here, right? Here magnitude not required, I think so. Here it is minus a is directly proportional to x you can take, right? Now let us see the next question. A particle of mass 0.1 kg is subject to a force which varies with the distance is given as shown in figure. It starts journey from the rest at x equal to 0, then its velocity at x equal to 12 meters they are asking. Now here the graph is given, force and displacement graph, you know, here it gives the work done. So here they are asking here velocity at x equal to 12 meters distance they are asking. So work done you can calculate here. Work done is nothing but here you will be getting as area under the fs graph you can take, area under fs curve. It's a here it's a trapezium is given. Here work done is nothing but here area you can take. Here area is nothing but here you can get it as half into so here you can get it as half into here you can take the sum of the two sides. Here you will be getting as the formula will be half into a plus b into height will be getting a plus the sum of the two sides we can take, this is 12 plus here you will be getting as this sides will be getting as 4 will be getting, and here to here it will be 12, and this side will be here 8 minus 4 will be getting as 4 will be getting, height is nothing but here will be getting as 10 will be getting, so into 10 you can take. So here are 2 5s are, so here will be getting as 12 plus 4 here 16 into 5 will be getting as 80 will be getting. Work done value here at the work done here will be getting as 8 joules will be getting by the curve. Now here it is going to be acquiring some kinetic energy is given during this work done. So here you can get it as Work done equal to, you can write as change in kinetic energy. Here you can get it as half mv square. Initial kinetic energy you can consider as 0. Here which will be equal to here half into mass. Mass value here it is given as 0.1 kg it's given into v square, which will be equal to 80 joules it's given. So here you have to simplify this one. V square equal to, here will be getting as 2 into 80, 160 will be getting 160 by here 0.1, and here it will coming as 1600 will be getting. Then velocity here you will be getting as 40 meter per second will be getting. So this is the velocity. So it starts its journey at x equal to 0, means initial velocity also you have to consider 0 at x equal to 0. So work done is nothing but change in kinetic energy of the system you can take. So the final velocity at x equal to 12 meters you are getting as 40 meter per second you are getting. Let us see the next question. Here a velocity time graph of a particle moving on a straight line lies as shown in figure is given. Mass of the particle is 2 kg. Work done by all the forces acting on the particle in a time interval t equal to 0 to t equal to 10 seconds you can take. So work done by here all the forces which will be equal to, here you can take as final kinetic energy minus initial kinetic energy you can take. It's nothing but half m v2 square minus half m v1 square you can take. So from the graph here we will be getting as work done which will be equal to half into mass will be given as 2 kg into v2 square. Final velocity will be here according to the graph here will be getting as 20 whole square. This is minus 20 whole square minus half into 2 into initial velocity will be getting as 10 square you are getting. So 2 gets cancelled here. This is 400 minus 100 will be getting. It's nothing but here will be getting as 300 joules you are getting. So 300 joules is the correct answer. Let us see the next question. The next question says here a car is going to be weighing 1400 kg, is moving at a speed of 54 km per hour. 54 km per hour up a hill when the motor stops. If it is just able to reach the destination which is at a height of 10 meters. So a car is going to be reaching certain height it's given. It's going to be reaching certain height it's given. Here are 10 meters is given. So here initial velocity will be getting as 54 km per hour. Here you have to convert 5 by 18. And here 18 3 here will be getting as 15 meter per second will be getting. This is the initial velocity of the car you can take. Now here after reaching the destination it has been stopped. So work done here by all the forces which will be equal to change in kinetic energy you can take. Work done by all the forces is nothing but here we will be getting as 2 forces is going to be acting. One is gravitational force and second one is the here against the friction, means some frictional force is going to be acting. You can take here which will be equal to half into m into, here you can get it as, this is here a final kinetic energy, right? Final kinetic energy will be 0 minus initial kinetic energy you can take as half mv square you can take. Work done against the gravitational force is minus, work done with the frictional force also will be getting as minus will be getting. So here minus you are eliminating in the sense together he will be getting as work done by the gravitational force plus work done by the frictional force which will be equal to half mv square you are getting. Now here you have to simplify this one. Work done by the gravitational force in the sense here mgh. Mg is nothing but here I will be getting as half into mgh. Mass is given as, here it is 1400 kg it's given into g value you can take as 10. Height it is reaching as 10 it's given. Plus work done by the frictional force you have to take half into mass it is given as 1400 into, here a velocity I have converted already 15 there will be getting as 225 will be getting. So here will be getting this is 700 times. So here work done by the frictional force, when you are simplifying this one you will be getting as nearly, this is 17,500 joules you are getting. So this is a work done by the frictional force. So it's nothing but here you can write it as here we can write in terms of the 10 power 3. You can write it as 17.5 into 10 power 3 joules you can take. So this is the correct answer. Let us see the next question. A body of mass 5 kg has a linear momentum is given as 20 kg meter per second. If a constant force of 5 newtons acts on it, the direction of the motion for 10 seconds they are asking. Initially here its momentum is given as, here it is 20 kg meter per second. And here its mass, here it's 5. Initial velocity we don't know, u equals to 20. Then initial velocity will be getting as 5 4 times. Here we will be getting as 4 meter per second we will be getting. And here work done by the constant force they have given. So here change in kinetic energy of the body. Work done we need to calculate. First for displacement, here S equal to, here you can take as ut plus half at square you can take. Initial velocity will be getting as 4. Here it is moving, it is under motion for 10 seconds plus half into acceleration in the sense f by m you can take. A equal to f by m. Force value will be 5 and here mass also will be 5. 5 by 5 will be getting as 1 into 10 whole square you can take. So displacement covered by the bodies, this is 40 and here 50. This is 100 by 2, 50. Here we will be getting as 90 meters you are getting. Then here work done equal to, here you can get as change in kinetic energy, which will be equal to, here you can get it as work done is nothing but, here you can take as force into displacement. Force into displacement you can take, which will be equal to change in kinetic energy. So force value already it's given as 5 newtons. So here you can get as, therefore change in kinetic energy is nothing but 5 into, here you can get as 90. So here we will be getting as 450 joules you are getting. So 450 joules is the correct answer. Let us see the next question. Two bodies of masses 2 kg and 8 kg are at a rest. The ratio of the distances travelled by them before they attain the same kinetic energy. So work done by all the forces which will be equal to change in kinetic energy you are getting, kf minus ke initial you can take. So work done is nothing but force into displacement, which will be equal to before they attain the same kinetic energy. Initially both the bodies are starting from the rest. So here you can take half mv square minus 0 you can take. This is the kinetic energy you can take. So F into S, which will be equal to K you can take, kinetic energy. Nothing but displacement, which will be equal to, here we will be getting as K by F you are getting. For both the bodies here by them before attain the same kinetic energy, same kinetic is given and same force is going to be acting, same force is going to be acting. So the ratios also of the distance covered is nothing but, here this everything is constant means 1:1 you can take. Let us see the next question. A car without passengers, here moving with a certain velocity on the level ground, can be stopped in a distance 10 meters is given. If the passengers are added 25% of its weight, its stopping distance for the same braking force and the velocity they are asking. Now here a car is going to be moving without passengers on a certain velocity on the level ground and stopped at a distance 10 meters. First you just calculate work done is nothing but, here you can get it as change in kinetic energy of the system. Here work done is nothing but force into displacement of the car you can take, which is change in kinetic energy you can take. Here the passengers are added, here braking force. This is a work done by the braking force you can take, it's an opposing force. So initially here you can get it as force and displacement both will be in opposite direction. Initially here it is traveling 10 meters distance, which will be equal to, here you can get it as 25%. If the passengers are adding, here 25% of its weight. Now final kinetic energy you can take as 0, initial kinetic energy you can take as half mv square. Let us see, this is the first case. In the next case you are adding 25% of its weight you are going to be adding, and here you are applying the retarding force again. and what is the distance covered, then f into x, which will be equal to, here you can get it as 0 minus half into, so x, this is the initial mass actually. With this here 25% of mass you are going to be adding by m into, here you can take as v square you can take. Let us take this is 2. So you have to simplify these two equations. Here 1 and 2 you can take. Here minus gets cancelled, ff gets cancelled. Here we will be getting as 10 by x we will be getting. Here half and minus you have to cancel. Here we will be getting as mv square by m, if I am taking common, here you will be getting as 100 plus 25 will be 125 by 100 into v square you are getting. V square gets cancelled, gets cancelled. Here 10 by x, which will be equal to 100 by, you will be getting as 125 will be getting. 25 4s are 25 5s are will be getting. 5 10s are 50 by 4. So x value will be getting as 50 by 4, which is nothing but you will be getting as 12.5 meters will be getting. Let us see the next question. A 1 kg block is situated on a rough inclined plane, is connected to a spring, and spring constant is given as 100 Newton per meter. The block is released from the rest with the spring in the unstretched position. The block moves 10 centimeter along the incline before comes to the rest. So block initially it starts from the rest, and here finally it is going to be coming to the rest. And here what are the forces here? mg, it will be acting like this. Here normal reaction is going to be acting, and here it will be 37 degrees you can take. This is mg cos 37, and here this will be mg sin 37 will be getting. Now here one force will be the force due to the tensional force or spring force is going to be acting. Second one is the frictional force, and third thing is gravitational force is going to be acting. So here we can talk work done by the spring force plus work done by the gravitational force plus work done by the frictional force, which will be equal to, you can write as change in kinetic energy of the system. So work done by the spring force is nothing but, here when you are releasing, here spring force is the conservative force, so it stores some energy. Work done by the spring force is nothing but, here elastic potential energy stored in the spring you will be taking, that is minus half kx square. So gravitational force is going to be acting right toward this side. Here that is mg into, here displacement, here you can take as some x you can take, into you will be getting as, this is sin 37 degrees you can take, mg sin 37 into displacement minus work done by the frictional force. Here frictional force is going to be, it's moving down in the sense frictional force is going to be acting, both frictional force and displacement both in opposite direction. So here you can take f equal to mu into n in the sense mg cos 37 degrees you are getting. So here minus mu mg into cos 37 degrees into some x. So final velocity and initial velocity both will be 0, and here we will be getting a 0 will be getting. So here the block moves 10 centimeter already it's given, you just put the values, minus half into k value will be getting as 100 into, this is 0.1 whole square plus 1 into mass value is 1 kg, g you can take as 10 you can take, here x is nothing but 0.1 meter you can take, 37 sin 37 value will be getting as 3 by 5 minus mu into 1 into g value you can take as 10 into cos 37 value you can take as 4 by 5 you can take, this is 37 degrees, this is 3 4 5 will be getting, cos 37 value will be 4 by 5 will be getting into 0.1 here, which will be equal to 0. So when you are substituting all the values here, mu value nearly will be getting as here 1 by 8 is the correct answer.